Hey everyone, and welcome to another deep dive. If you absolutely love unpacking the intricate, sometimes totally mind-bending rules of our reality, well, you're in the exact right place today. Welcome to today's explainer, Planetary Physics and the Mechanics of Catastrophe. We're going to be examining the invisible threads that hold our entire world together, and we're going to do that by exploring exactly what happens when those threads suddenly just snap.
Okay, let's dive right in by asking what is arguably the ultimate catastrophic thought experiment. What if the world just stopped? Picture this. You're just going about your morning, totally relying on the steady, completely invisible spin of our globe. If that motion were to cease in a fraction of a second, well, it's basically the planetary equivalent of a car going 1,000 miles an hour and instantly hitting a brick wall.
All right, let's get into Section 1, the mechanics of catastrophe.
So we're talking about an absolutely unfathomable momentum shift here. Think about it. If the Earth abruptly becomes completely stationary, everything that isn't firmly anchored to bedrock, so the atmosphere, the oceans, and us, instantly continues moving at the Earth's previous rotational speed. That means supersonic winds sweeping across the continents at roughly 1,000 miles an hour and literal tsunamis miles high. The sheer kinetic energy unleashed would be a mechanical catastrophe happening in the literal blink of an eye. Moving on to Section 2, when the Earth stops.
And this comparison really hits the nail on the head. You've got that catastrophic halt we just talked about. Just total, absolute environmental chaos. But contrast that with the perfect, beautiful harmony of our everyday diurnal cycles. It's a stark contrast that perfectly captures the difference between a broken physical law and the incredibly stable physics that quietly regulate our global temperatures and weather systems every single day. So, the crucial point here is understanding these diurnal cycles. What are they? By definition, these are the daily, repetitive patterns tied to the Earth's rotation. Basically, our rhythm of day and night. It seems like such a mundane, boring detail of your daily routine, right? But it's actually this beautiful, incredibly precise mechanic. This continuous rotation regulates our environment so perfectly, it completely masks the fact that we are constantly spinning through space at mind-boggling speeds.
Let's shift gears a bit for Section 3, Secrets of the Sphere.
Now, this brings up a question that honestly sounds kind of like something a kid would ask, but it's actually profoundly deep. Why don't we fall off a spherical world? I mean, we're living on the surface of a giant sphere spinning in a literal vacuum. The gravitational pull pulling us toward the core is so perfectly calibrated that it completely overpowers the centrifugal force trying to fling us off into space. It's an absolute miracle of mass that we rarely give a second thought to.
To really wrap your head around the sheer scale of this planetary grip, just consider our massive oceans. They aren't just pure water. Seawater is roughly 96% water, and the other 4% is dissolved salts and minerals. That specific chemical composition makes our oceans incredibly dense and heavy. And yet, gravity is strong enough to keep this vast, dynamic, incredibly heavy chemical soup clinging perfectly to the curved surface of our spinning world. It's wild.
Let's escalate the stakes one last time. In Section 4, a world without gravity.
Okay, what if that gravitational force suddenly just disappeared? The chaotic aftermath would unfold instantly. Step 1, bam! Our life-giving atmosphere immediately detaches and vents straight out into the vacuum of space. Step 2, those massive, super dense oceans we just analyzed, they lift directly off the surface. Step 3, without gravity holding everything together against the Earth's rotational spin, the crust itself undergoes a catastrophic unbinding. It would be a sudden, clinical, zero-gravity apocalypse. No warning, just everything coming apart.
So, you might be wondering, why model these absolute worst-case scenarios at all? Well, it's because it fosters a much deeper appreciation for the incredibly delicate physical laws that are sustaining our environment right now. Every time you take a breath or, just watch a sunset, you are witnessing a finely tuned mechanical masterpiece. Understanding these invisible wonders really shifts how we value our everyday mundane reality.
I want to leave you with this final provocative thought today. How completely do you rely on the physical laws of our environment? I really hope this explainer has given you a newfound awe for this magnificent, spinning, gravity-bound sphere we call home. Keep questioning those fundamental planetary mysteries, keep looking at the invisible mechanics behind our world, and most importantly, keep learning. Catch you next time.